Hi everyone, today we are talking about exponents and scientific notation. To start off, we're going to try to evaluate exponential, the integer exponents. First rule says, if a and b are real numbers, where b does not equal to 0 and n is a natural number is just the counting number that you count and does not including 0. Then the rule parenthesis a over b to the nth power, and you can just split them up, become a to the nth power and b to the nth power. It's literally like distribute both top and bottom, which is the numerator and the denominator. So based on that, we are going to practice few problems. So on question number 1, when they say distribute property, a lot of you guys makes the biggest mistake because you are looking at sign and not realize that also have to the 5th power. Technically, if you think about this problem, you really have -3, -3, -3, -3, and 5 of them. So really you are distribute the negative sign and the 3 because that negative sign is under the parenthesis and the 5 is to the whole thing raised to the -3 in parenthesis. So whatever this guy in here inside the parenthesis is going to be 5 times. So that's why you have to make sure that you understand that's what that means. And then because that you actually have 5 negative sign, so because it's because it's odd number, negative sign, negative become positive, positive negative become negative, negative become positive, and positive and negative become negative. And then it's going to be 3 to the 5th power, like that. And 3 to the 5th power is going to be -243. And that's your answer for that one. Again, that's one that most people make a mistake on. You have to understand that the -3, right here, I'm going to write it down. That is the base of this exponent. That's an exponent. So if that exponent is attached to a base, that base, for the whole base, is going to be multiplied whatever that exponent times. Okay? So you need to make sure you raise the power correctly. It's something I love to put it on the quizzes and tests so you will understand the rules even better. But a lot of you guys just punch in the calculator and just pray that you get the right answer. Now I want to show you the reason why that is the case. So in this one, you're going to say, oh, Miss Weisman, that is a positive 16, but it's really not. Remember I told you is the base and the exponent that is attached to that base going to be multiplied or raised to the power. So in this case, so the problem really comes down to be -2 times 2 times 2 times 2. The 4 is the base, so therefore the 2 is the base, so therefore the 2 is going to be multiplied 4 times, so it's -16, and that is the answer. Example number 3, or the third one, that follows the rule exactly. In this case, there's 2 ways of doing it. Number 1 is just thinking about this thing happened 3 times. I want you guys to imagine this, not just to follow the rules, but think about this is actually 3 times. So it's 4 to the 3rd power and 5 to the 3rd power. So you can split them up. Or another way you can think about it is going to be 4 over 5 and 4 over 5 and times 4 over 5. And now you can visually see, hey, I have 5 3 times. So it's going to be 3 times, so it's 5 to the third power. And 4 3 times, so it's a 4 to the third power. And this is not 4 times 4 times, this is not 4 times 3. This is 4 times 4 times 4. So 16 times 4 is going to be 64 over 5 times 5, 25 times another 5 is 125. And that is how the answer is supposed to be. Now, if you want to do this in the calculator, that's more than you can definitely do that. And the way to do it is you can do it again 2 ways. You can do parenthesis 4 over 5 parenthesis to the third power, or you can do 4 to the third power times 4 times 4 times 4 and press the enter, or 5 times 5 times 5, press the enter, and you'll have a number top and bottom. But I also want you to understand you can do that in one step if you want to. Now the next question is almost the same as the problem before. Now the problem before, if you look at it, I mean, that's like number 1. Now the problem is sometimes if you screwed up on putting the parenthesis in, you got to remember that that parenthesis is going to make a difference. Not in the odd situation, but in the even situation, you definitely make a difference. Because the negative sign is going to be even number of them. And if it's even number of them, you should know that become positive. So now let's think about this. The negative 4 is actually the base because that's inside the parenthesis. But then the 4 is going to be the exponent. So actually, your base is negative 4. The whole thing is going to be to the 4th power. And because of that, you will actually have negative 4 times negative 4 times negative 4 times negative 4 times. So that negative sign got to be also multiplied 4 times. But because it's even number, you should know that's going to be positive. And so that's going to be 16. Because if you write it out, it's going to be negative 4 times negative 4 times negative 4 times negative 4. Okay, because negative 4 is the base. And this is your exponent right here. Okay. Next rule is anything to the 0 power is 1. Again, it only is the base and the exponent, that part turns into 1. Okay, so in this case, 10 is a base and 0 is right next to it. So therefore, the 0 is the exponent. So that's going to be equal to 1. This is the base. This is the exponent. And the next one, the x is the base. And the 0 is the exponent. And because of that, the answer should also be 1. And the next one, it's a question I love to ask every single quiz and every single test. That is, you have to understand where's the exponent, what is your base. Now, because if you think about it, this is your exponent. So therefore, this is the base. 5 is not included in that whole thing. And that's going to be 5 times 1. That 1 is from x exponent to 0. That is become 1. And because that's 1, so the answer is actually 5. Be careful on that. I absolutely love that question because that you understand the rules of anything to the 0 power is 1. Okay, so pause the video and try it, the problems on the bottom, and see do you guys get the same exact answer. The answer for the next set of those examples that I asked you guys to pause is 1, 1, and negative 1. And again, it's the negative 7 because 7 is the base and 0 is the exponent. The negative 1 was not part of the 0 exponent, so that negative sign stays. So therefore, that's negative 1. The rest of them, the base raised to the exponent. Now you say, but Miss Wiesman, I can do all this in the calculator if I just punch in correctly. Sure, but the problem is this is just the basic. Most of the time, I will actually ask you guys related to the letters. So if you don't know your rules, you will not be able to figure out based on the letters, because that's something that calculator cannot punch it in for. And then I do expect to see the proper work like what I teach you guys. So if you try to use any other device and they show you different things, I will notice right away, because the way they do their problems is not the same I do mine. So the next rule is, if a is a real number where a does not equal to 0 and n is a natural number, then a to the negative n power equals 1 over a to the nth. Now, there's a reason why we cannot have a equals 0. Because a equals 0, that means denominator equal to 0. That doesn't work. But the n is a natural number. N is just any kind of positive numbers, but not that small. And this rule will apply. Okay, so let's take a look at some problem. Now, one thing I would like you guys to understand is we are talking about the very important thing on here is understand we are talking about the exponent negative number. So if the exponent is a negative number, you flip the top to the bottom and bottom to the top. It's because it's the exponent. Okay, so now on the first one, for the first one, I want you guys to understand which negative sign we are looking at. Again, we are looking at the exponent negative sign. So it's this sign makes it flip. So because that's on top, numerator, so flip it to the bottom, it's going to be 1 over negative 2 to the 4th power. Did you notice that negative sign is gone, but the 4 stays? I did not change any other sign. And then when you flip it over and then simplify it, that's negative 2 times negative 2 times negative 2 times negative 2, because your base is negative 2. So there's 4 negative sign, therefore become positive. So 1 over 16. And yes, you can totally do this in the calculator. That's provided if you can punch it in correctly. The next one, give it a try and then come back and see, do you have the same answer? I have the answer for the next one is negative 125. Again, because this negative sign, not the one in front of the 5, because negative 5 is the base. We are looking at the exponent. Again, right here is the exponent. All right. Now, because that exponent is negative, we can flip it from the top to the bottom, and then negative 3 become positive 3, and then negative 5 stays, and that's going to be 125 3 times, and then so therefore negative sign stays. I'm sorry, negative 5 3 times, and then so negative sign stays, but negative on the bottom can definitely be put in the middle in the division sign. So the answer, you can write it the first one, 1 over negative 125, or negative 1 over 125. Either one I will take. Try the next couple and see do you get the same answer. Pause the video. Please double check your answer. Next example is x equals negative 6. And because that negative 6, it gets flipped to the bottom. And because it flips to the bottom, it's 1 over x to the 6th power. And that is it. There's nothing else to do. For the next one is 2 to the a to the negative 3. And because a is the base, not 2, a is the only thing gets flipped. And that negative 3 will be the exponent. So a attached to the negative 3, that is the only thing gets flipped. So 1 is 2 times 1 over a to the 3rd power. And therefore 2 times 1, because that's in the numerator, and then a to the 3rd is on the bottom. Let's try to do the next one together because it's a little bit tricky. The next one is negative 6, 1 over to the negative 2 power. That is going to be really negative times 6, Now 6 is the only one gets flipped, not the negative sign, doesn't make any difference. So it's going to be 1 over 6 to the second power. And because that is, your answer is going to be 6 times 6, that's negative 36. And your answer is going to be negative 1 over 36. Okay, now if you decide to put the parenthesis on there, you will get the wrong answer because it doesn't give you that negative sign correctly. Going on to the next problem. Okay, now because we've done all the things from the numerator flip to the denominator, I want to show you one that's actually in the denominator flip to the top. So since in the denominator, I told you guys if it's on the top, flip to the bottom's flip to the top. That means that negative 4, that negative sign tells you to flip. So that's going to be flip to the top, and that's 3 to the 4th power, negative sign's gone, over 1. And if it's over 1, you don't really have to write it. That's going to be just 3 to the 4th power, and that's going to be 81. And that's your answer. And let's try the next one. Why don't you guys try the next one and see, can you get the same answer? Okay, looking for the next one, it's a letter in the bottom, in the denominator. So when you flip it to the top, it's going to be x to the 5th power, negative sign is gone. And then since it's x to the 5th power over 1, you can just get rid of the 1. So the answer is x to the 5th. Now, some things that you guys absolutely hate, a fraction. Don't worry, it's really, really easy. And then in this case, think about your very first rule and this last rule. If you write it properly, I told you guys if it's in parentheses like this, you can split them up into negative 3 like that. And then 4 to the negative 3. But that looks very complicated. And then I had to flip top and bottom everywhere. So I will try to work through inside and before I multiply because I usually like to work with a positive exponent. So let's try this way. I'm going to erase that. That's the one way you can do it correctly. So I would like to say, okay, I have a negative sign here. And Miss Wiesman told me if the number's on top, flip to the bottom. If the bottom number, flip to the top. So I'm going to just do a quick swap. It's going to be 4 over 3 into the 3rd power. Did you notice it's 3 over 4 now become 4 over 3? That's all. The reason for that is because negative 4 will get a negative sign. 3 will get a negative sign. And then just like what I wrote it before, instead of writing it everywhere, I can just flip it. And why should I go through so many extra work? Because the negative sign on top, right here, is going to flip to the bottom. The negative sign on the bottom is going to flip to the top. So that's what I just did. And then I can say, oh yeah, 4 to the 3rd power is much easier. You guys get much better at dealing with those. 4 to the 3rd power is 216. And then 3 to the 3rd power is not 9. Please do not give me 9. I know some of you guys will say, oh, that's 9. No. It's 3 times 3 times 3, so it's going to be 27. And there's your answer. And yes, Ms. Wiesman, I will tell, yes, Ms. Wiesman, can I use a calculator? Yes, absolutely. But make sure you understand how to handle it when it's letter, because that's what I will give you. Okay? And the next one is going to be the same kind of things. Now, because that negative sign is right here, is not the sign in front of the fraction, we keep that fraction negative sign. So it really is flip, top, bottom, but everybody to the 3rd power. Does that make sense? Notice my 5 is numerator, goes onto the denominator. It was in the denominator, go to numerator. And the other one is in the numerator, become denominator. Then we understand that negative sign has to be distributed 3 times, but you know that's going to be an odd number of negative sign. So this problem is going to stay as negative. And 5 to the third power is going to be 5 times 5 times 5, that's 125. And then 4 to the third power is 4 times 4 times 4, therefore it's 64. So that is your correct answer right there, negative 125 over 64. I don't want it in decimal. Please do not give it to me in decimal. If you don't know how to use your calculator correctly, please ask me. I'll show you how to put it in so you will get your fraction. Please try the next example and see do you get the same answer. Pause your video and come back to it. I'll put the answer down. The answer for the next one is going to be y to the fourth over x to the fourth, and that is it. All right, next thing we're going to do is we are going to try scientific notation. And some of you guys are really good with this because you guys done, freshman year, you done it your sophomore year for chemistry. So now we're going to review it one more time. Now I want you guys, sometimes you get confused with the left and right. I want you to think about, does this make the number bigger or smaller? Okay, if it's bigger, you know how to make the number bigger. If it's smaller, it's got to be right like a decimal. So please try to think about it when you do the problems because it will make sense to you. So scientific notation to standard form. Scientific notation is made of one number, one digit to the left of the decimal, one digit. So it's one digit to the left of the decimal and whatever number goes on the bottom and next to it and times 10 to the whatever exponent. Okay, and that's the basic form. One digit is going to be from 1 through 9. Everything else can be on the outside. I don't like the squiggly line. Let's say 1 to 9. Okay, so that is going to be the number right here, and those are the numbers right here. And there's going to be a number right up here. Okay, so I hope you guys understand the form. All right, so let's take a look at this. Next, the first one is the scientific notation changing into the regular number. Now, I want you to understand this is not a positive 5. And because that's a positive exponent, you know positive exponent is going to make numbers bigger. And so in this case, I'm going to take this decimal and make my number in the front bigger. Now, how do you do that? Well, which way is going to make this number bigger? Well, the decimal has to go to the right. Now, why is it sometimes you guys get confused? Does it go right? Does it go left? It all because the way the number's written depends. Are you changing it from standard form to scientific notation, or do you go from scientific notation back to standard form? So sometimes it gets confusing because you never understand which way, which is the base that you are looking at. So in this case, I want you to think about it, common sense, because I 10 to the fifth power, you guys understand 10 to the fifth power, it's got to be making the number bigger. And because that's making the number bigger, your 4.5 has got to be bigger number. So what we're going to do is we're going to say, okay, my decimal is right here. Because my exponent is 5, I'm going to move my decimal 5 spots. 1, 2, 3, 4, 5. Because there's number there, so I'm just going to be making my little space and then put in the 0. 1, 2, 3, 4. That means your decimal is now here. So your number is going to be 4, 5, 0, 0, 0, 0, 40. So it's 450,000. That's your number from scientific notation to standard form. So you guys try the next one. The answer for the next one is the decimal ends up at the end on the right hand side of the 7, which is right here. And then because the exponent is 8 times, I need to have 8 decimal places after the 7. So when I'm making the little curvy sign, I have 1, 2, 3, 4, 5, 6, 7, 8. And then there's my decimal. So my decimal from here move down to here. And because of that move, I need to add in my zeros. So there will be 8 zeros. So by putting the comma in every 3, I will have 700 million. The next one is kind of just the opposite. I want you guys to notice that the exponents in this case is actually a negative. Now, we already know that negative numbers is going to be making it smaller. Positive makes bigger and negative makes it smaller. So what we're going to do is we are going to, instead of making the number bigger, how do you make 4.5 even smaller? Well, that means the decimal had to move it to the left. So because the decimal is between 4 and 5, I'm going to write it down right here. And then I'm going to move the decimal place to the left by 3 places. So it's 1, 2, 3, because that's 3 places. And there's my new decimal. So it's going to be filled with a 0, and it's going to be 0.0045. That's your answer. And try the next couple. Now think about it. If it's a negative exponent, your number should be smaller. Okay, so the next example is 9 times 10 to the negative 7. Again, it's a negative 7. So the number should be smaller than the 9 or the original problems that you have, which is right here. That is going to be smaller than 9. And how do you go smaller than the 9? That the decimal has to go towards the left-hand side. And then I already counted from the decimal place because they don't have one. The decimal goes in right there. And then you move 9 places from that decimal and you count it. I usually do my little curvy lines, and that's 7 spaces. So 60 because including 9. And there's going to be 1, 2, 3, 4, 5, 6, 6, 0 with a 9. That's the answer for the next one. And the one after that, you have a negative 6 as your exponent. So again, it's going to be negative, and therefore the number has to get smaller. And when the number gets smaller from 7.24, it has to go towards the left-hand side. And when you go to the left-hand side, you start with your decimal at where 7 after the decimal. 7 is the decimal is after the 7. So if you count 6 times, you're gonna fill in 5 zeros, and that 5 zero puts the decimal on the left hand side of the 5 zero. So the answer is 0.00000724. But do you guys notice if you have an exponent, the number gets smaller on your exponents? Okay, and let's take a look at the next set of problems. Next set of problems says write the standard form numbers in scientific notations. Okay, so this still apply the same idea we are talking about. So I want you guys to think about this. Okay, first of all, understand the form is only 1 digit to the left hand of the decimal. So if they don't have a decimal to start, your decimal starts with at the very end. And then you're going to do 1, 2, 3, 4, 5, 6, because 1 digit have to be on the left hand of the decimal. And that's 1 digit. So in this case, it's going to be 5 times 10 to the, hey, it's a big, huge positive number. So therefore, the number has to be positive. Okay, the number has to be positive. So in this case, because you have to make it positive big numbers, your exponent is going to be positive. You are taking the 5, making it a bigger number that's going to be positive, so the positive exponent. So it's going to be 6 times. Please try the next few problems yourself. 3.1345786 times 10 to the 7th. And the reason for that is because I have the decimal starts at right here. Okay? Because there's no other decimal. And then again, I have to be in the form 1 digit to the left of the decimal. So 1 digit to the left of the decimal. So that's what I have to end up with. And because I have to end up with there, what I have to do is I need to count backwards. So it's 1, 2, 3, 4, 5, 6, 7, and that's where it puts my new decimal, and that's where I get the 3.13 and blah blah blah. And then because it's 7 places, and because it's a big number, I'm going to have positive exponents. That's it. Okay, and the next one is a little bit different because it's a very small number, so therefore I'm going to move it to one decimal place, which is right here. I need to one decimal place to the left hand side to make a scientific notation. So it's going to be 1.234 times 10 to the, it's a very small number, 0 point something. I'm going to do -1 because I only move one space, and from this decimal, I'm going to move it to here because it's one place over the left hand side decimal. That's where it is going to end up at. And because I'm making this, because it's a small number, it's going to be -1. Then the next one, you guys try it and we will compare the answers. The next one is going to be, again, a small number, very small number. So to make them into a bigger number, because 6.78 is definitely bigger than 0.000067, making it bigger, so it's going to be negative exponent, or you can think about it, that's a very small number. And because of that, it's going to be a negative exponent, first of all. Now, how do I know number 6 of them? Well, it's because my decimal is right here, and then to move it into the proper form, the decimal going to end up right here. So from here, I'm going to do 1, 2, 3, 4, 5, 6 right here, and that because of that, that's where my 6 come from. And the new form with the decimal is going to be 6.78, and there's a 6.78, and that will be your answer. That concludes the notes for the exponents and scientific notation for today. If you have any question, please let me know. Thank you for watching.